On page 159, number 11, we've got a sewing basket with 8 reels of cotton. We've got 4 of them are green, 3 of them are red, and 1 is yellow. 3 of the reels are removed at random. So let's put our information down here so we can see it. And remember what we got to do? We're selecting 3 random. Now, it says show that the expected number of yellow cotton reels is 0.375. So that's the same thing as expected value, which we know is going to be the x's times the probabilities all added up. And since there's only 1 reel that's yellow, we've only got 2 possibilities. Either there's 0 pulled out or 1 pulled out. So if I want to know the probability of getting 0, well, that's going to be one of the yellows choosing 0, and then the 7 others choosing 3, all divided by 8 choose 3. And that's going to give me a probability of 5/8. And then if I want the probability of getting 1 yellow, well, that's 1 choose 1 of the yellows, and then 7 choose 2 of the others, all divided by 8 choose 3. And that's going to give me a probability of 3/8, which makes sense because they should add up together to be 8/8. So now all I've got to do to find the expected value is going to be to multiply the x's times their probability. In this case, it's just going to be 1 times 3/8. 3/8 is 0.375. Now, in part B, it says find the expected number of red reels. All right, so we're going to do pretty much the same thing. In this case, though, there are 3 reds. So that means we could get 0, 1, 2, 3 red reels out. So we've got to find each probability. But we're going to do it the same way. So to find the probability of it being 0, that's going to be choosing 0 of the 3 reds, and then I have to choose 3 out of the 5 others, and I'm going to divide by 8 choose 3. And if I want to find the probability of getting 1 red, well, that's going to be choosing 1 out of the 3 reds times 5 choose 2 of the others, and again all divided by 8 choose 3. And then for finding the probability of 2 and 3, we're going to do pretty much the same kind of thing. And what we're going to end up with then is we're going to find that the probability of 0 is 5/28, and the probability of getting 1 is 15/28, the probability of getting 2 is 15/56, and the probability of getting 1 is 1/56. And now we've got our values for R, and then we've got each associated probability. And then to find the expected value, all we've got to do is use the formula of each R times its probability. In this case, 0 times 5/28 is going to be 0, but I am still going to do 15/28 times 1 plus 2 times 15/56 plus 3 times 1/56. And then all I've got to do is add all those up, and I'm going to find out that I get a 1.125 for an expected value. Now, you didn't have to do part C, but in part C, all they're saying is if we did these other 2, we should be easy able to figure out the third one, because at the end of the day, we're removing 3 reels. And if we expect to get 0.375 yellows, and if we expect to get 1.125 reds, well, then we should just be able to do 3 minus 0.375 minus 1.25 to find out the number of greens we should expect to get, which would end up to be 1.5 reels of green would be the expected value. All right, let's go on to the next one. In problem number 13, we've got a scout troop, and it's got 8 juniors and 12 seniors in it. And they meet every Monday evening, and one person is randomly selected to hoist the flag. They want the variable x to represent the number of juniors that are selected over a series of weeks or Mondays. Now keep in mind, this is not like a marble problem where if I pull a marble out, it's going to change the probability of what's in the bag. Each Monday, the probability resets. And so it's possible for the same junior or senior to get picked 1, 2, 3 weeks in a row. So we got to keep that in mind when we're going to do this. First, we'll look at the probability of getting 0 juniors. Now, that means that we're going to have 12 out of 20 is the probability of getting a senior. And that means each week it's going to be 12 out of 20 to get a senior. So if that happens 3 times, well, that's going to be 1,728 over 8,000. Now the probability of getting one junior, well, now that's 8 out of 20 times 12 over 20, and then another 12 over 20. In this scenario, the first week we picked a junior, and the next week we picked a senior, and the next week we picked a senior. Now the thing is, that doesn't have to happen in that order. It could have been in a different order. So we got to multiply that by the different ways it could be arranged. And you could lay it out like this, and you could tell that it could be 6, or you could look at the permutation of these and realize that 2 of them are identical, and when we arrange them, it's going to be 3 factorial over 2 factorial, and anyway, it's going to be 3. And so when I multiply all that together, I'm going to find out the probability of one junior being picked over 3 weeks is 3,456 over 8,000. Now I'm going to do the 2 juniors the same way. It'll be 8 over 20 times 8 over 20, but then times 12 over 20. Now that's getting me a junior, and then a junior, and then a non-junior. But that also could be arranged in 3 factorial over 2 factorial ways, or 3. And so that's going to give me a total probability for 2 juniors being selected as 2,304 over 8,000. And then 3 juniors being selected, well, that's 8 over 20 times 8 over 20 times 8 over 20. And that's going to give me a probability of 512 over 8,000. That can only happen one way. Now, all I've got to do is double check and add up my numbers and make sure I should get 8,000 over 8,000, and I do. And so now I can lay out a probability distribution table, and my x's are going to be 0, 1, 2, and 3. And then the probability of each I've just figured out, and I'm going to reduce them in this case because I know I'm going to find the expected value, and it'll be easier if the numbers are smaller. So 27 over 125 and 54 over 125, 36 over 125, and 8 over 125. And so the expected value is each x times its probability, all added up. And that's going to give me 0 times 27 over 125 plus 1 times 54 over 125 plus 2 times 36 over 125 plus 3 times 8 over 25, all added up. And that's going to give me a probability of 6 over 5, or 1.2. Okay, I hope that made sense. Let's go on to the next one. In problem number 14, we've got an ordinary die, and we're rolling it. If we get an odd number, then we get whatever number we get. And if it's an even number, we get to roll again. And if on the second roll it's odd, well, then we get that number. If we roll an even number on the second roll, however, then we only get half of whatever we get. So let's kind of lay this out so we can understand what's going on with these rolls. If I have the first roll, and let's say I get an odd number. Let's say I get a 1, a 3, or a 5 in the first roll. Now, my score is going to be a 1, a 3, or a 5, because I'm going to get whatever I got if it's odd. Now, in another situation is, what if it's even, a 2, 4, or a 6? Well, now I'm going to roll a second time. And one possibility is that an odd number comes up, a 1, a 3, or a 5. Now, if a 1, a 3, or a 5 comes up on the second roll, I'm going to get that score. Now, the other possibility is that I roll an even number on the first roll, and then an even number on the second roll. Well, now what happens is I get half of the second roll. So it's going to be 2 divided by 2, 4 divided by 2, and 6 divided by 2, or 1, a 2, or a 3. Those are now my possible scores. All right, that's how this game works. And so let's figure out the probabilities. First, we can tell what possible scores I could get just by looking at the table we've made here. I could possibly get a 1, I could possibly get a 3, I could get a 5, and the other possible score is I could get a 2. So we've got to find the probability of each one of those scores happening in all the different ways they could happen. So the first thing we'll look at is probability of getting a 1. Well, one way I could do that is if on my first roll I get a 1. Now there's a 1/6 probability of that happening. Now there's other ways. I also could roll an even number first. If I roll an even number first, well, that's a 1/2 probability of getting an even number, because whatever even number I get, I'm going to roll again. So I'm not going to break it down to the specifics of 2, 4, or 6. I'm just going to say, is the first roll even? And the probability of that happening is a 1/2. Now, the next thing is I have to get a 1 in order to get a score of 1. Keep in mind, these are all about getting scores of 1. I get a 1 on the first roll, or I get an even and then a 1 on the second roll. Now, the third possibility is that I get an even on the first roll, but then I get a 2 on the second roll, which would be half or 1. So the probability of getting an even on the first roll is 1/2, and then the probability of getting a 2 on the second roll is a 1/6. So those are the three ways I could get a 1, and so to find the probability, I just add those up. I get 1/3. Now the probability of getting a 2, well, I can't get a 2 if I roll the first odd number, so now it has to be an even number, and so the probability of getting an even number is 1/2, and then the only way that can happen is if I get a 4 on the second roll. So that's going to be a 1/6. So the probability of getting a 2 is 1/12. Now the probability of getting a 3, that can happen a few different ways. I could get a 3 on the first roll. That's a 1/6 probability. I could get an even number and then get a 3. So that's a 1/2 times 1/6. And then the last possibility is to get an even number and then get a 6. So the probability of getting an even number is 1/2. And then the probability of getting a 6 is 1/6. So when I multiply those together, I'm going to find out the probability of getting a 3 is 1/3. And then the probability of getting a 4, no, there is no probability of getting a 4. The probability of getting a 5 is going to be, well, I could get it the first one, odd. And that's, let's see, I could get an even number and then a 5. And that's really the only two ways it can happen. So I can multiply those and add those, and I get a probability of 1/4. So now I'm going to go ahead and I'm going to make my probability distribution table. And these are S's. So the possible S's are 1, 2, 3, and 5. And the probability of each that I just found is going to be 1/3, 1/12, 1/3, and 1/4. And I should check and add those up and make sure that they actually equal 1. And after I do that, it says to find the probability that S is greater than E of S. Well, what they're saying is find the probability that S is greater than the expected value. So I've got to find the expected value to do that. And the way I'm going to find the expected value is I'm going to multiply each x times its probability, and then I'm going to add those up. So let's take a look at that. The expected value is going to be each one of these x's times their probabilities, and then all added up, which is going to be 1/3 plus 2 times 1/12 plus 3 times 1/3 plus 5 times 1/4. That's going to give me a probability, expected value of 11 over 4, or 2.75. Now, what they want to know, I haven't answered the question yet, is the probability that S is greater than 2.75. Well, that's going to be a 3 or a 5. So the probability of 1/3 plus 1/4, that's going to give me 7/12. That's the answer to B. Now, in C, they ask for the variance. Well, I'm going to take my calculator, where I've already figured out the expected value. I'm just going to go back and change all those x's to x squares, and then subtract the expected value I just found squared. And that's going to give me my answer, which is going to be 113 over 48. Now, the thing is, I can't just write the answer. I have to write down what I did, and I can't say I used the calculator. So here's the formula that I'm going to use. It's going to be the sum of the x squares times the probabilities minus the expected value squared. And so all I'm going to do now is write what I just put in the calculator. 1 times 1/3 plus 4 times 1/12 plus, whoops, that's a 9. 9 times 1/3 plus 25 times 1/4, and take away 2.75 squared, and then I can put the answer is 113 over 48. And that's all there is for that one. All right, let's take a look at the next one.